Evaluate limit. Explain why the limits of limit x approaching 3 of x squared minus 9 divided by x minus 3 exists even though the function is discontinuous at 3. Well, let's look into the function and its limit. Now it could be written as limit x, first let me copy it as such, okay, x squared minus 9 over x minus 3. Yes, of course, the restriction is that denominator can never be 0. So we have here that x is not equal to 3. So if I put x equals to 3, then I'll get what? Let's check. If I put x equals to 3, what do I get? Okay, so 3 squared is 9, so we get 9 minus 9 over 3 minus 3, right? We get 0 over 0, right? Which is meaningless, right? So if you do direct substitution, you don't get any limit. But you know what? Limit is not at a point. Limit is what the function value will be when you are approaching that point. So you may not be at that point, but you have to be close, and very, very close to that point to understand what the limit is at that point. So that is why there is a possibility of having limit for this function even at a point where the function is discontinuous. That's the beauty of limit, right? So we are trying to understand even a point which we cannot reach. That's the concept. So let's try to see, well, if it exists, what is its value? For that, what we will do is, we'll try to simplify it. Now, 0 over 0 gives us a hint that x minus 3 should be a factor of numerator also. Otherwise, we won't get 0 by placing x as 3. So let's factor the numerator. So when we factor the numerator, we get its difference of squares, x squared minus 3 squared. So it could be written as x plus 3 times x minus 3. And in the denominator, we get x minus 3 as it is. Now you see, x minus 3 and x minus 3 cancel out, right? Or you can say x minus 3 divided by x minus 3 is 1, and therefore we have limit x approaching 3 equals to x plus 3. And of course, x is not equal to 3. Perfect. That is equivalent to this expression. Is it okay? Absolutely same. So what does this show us? It says it's a straight line, x plus 3. So line with a slope of 1 and y-intercept of 3, like this, correct? But in this line, at x equals to 3, let's say this is our point. There is a hole at x equals to 3. Let's say this is 3. So the line is everything but a hole at x equals to 3. Do you see that? Now the question here is, can you find limit of this function? If you approach from the left side, look at it like this. If you are approaching from the left side, that is, left side is this side, close to 3, which point do you approach? You approach this point, right? If you approach from right side, you again approach to this point. What is the value of this point? If you plug in x equals to 3, 3 plus 3 is 6. So this value actually is 6. So from both left side and from right side, that is, the limit of the function as x approaches 3 from the minus side is equal to what? That is, from this side is 6, right? And limit of the function when you approach 3 from positive side is what? It is also 6, right? We are writing function here and we are assuming this limit of, we're talking about limit of the function, okay? Yeah, so limit of the function as you approach 3 from both the sides is same and it is equal to 6. Therefore, by definition of limit, limit exists and the value is 6. So we can write here limit of this function is actually equal to, so we say limit of this is equal to 3 plus 3, which is 6, correct? So we substituted this 3 here now because we are approaching very, very close to 3, right? And that is how we can explain that the function is discontinuous. It has a hole there, right? But limit is not the value of function at that point. Limit is what value do we approach when the x becomes closer and closer to that value. So when x becomes closer to 3, we are approaching value of 6. Therefore, the limit exists and it is 6 for the given function.